So if you're doing anything in 3D animation, 3D modeling, 3D game development, whatever, you've run into having to use normal maps and needing to understand what in the world is a normal. Well, in the simplest terms, a normal is the direction that a face is orientated. So we've got a cube here to show you, and the normal for this face over here is pointing exactly in that direction, right? So I am very bad at drawing, but this face is orientated in that direction, and this face is orientated straight up, and this face is orientated in that direction, so on and so forth. Just imagine for a second that these lines are straight. That's pretty annoying to have to draw into Blender though, to really get a feel for it. So luckily Blender has a function built in for that. And that's if we go into edit mode by pressing the tab key. In the overlay menu, we've got a couple of options for normals, and it's got 3 different views. The most important one being the face normal. We can increase the size a little bit, and it will show you a line of the direction that any face is orientated. So this way we can see the face normals. Vertices themselves also have normals, and they just point out from the vertice itself. For the most part, vertex normals aren't as relevant as face normals. Most of the time you're going to be worrying about that. But having a vertex normal out of whack can cause some weird lighting glitches and stuff like that. So it is worth paying attention to. And then the last one is your split normals, which is the normals along the lines, the edges that you have in your model. Again, this video is mostly about the face normals because those are the ones that you're going to be worrying about most of the time. Those are the ones that normal maps are using. Which brings us to a normal map. So I really quickly downloaded this normal map of the internet, and if we just plug that in real quick here, we can suddenly see detail on a image that doesn't have an image texture. And that's because a normal map uses a RGB data, which is just an image, to store the X, Y, and Z rotation on a pixel basis. So whereas before we had the normals represented on a per face basis, so that's based on the actual geometry of the object itself, a normal map will just project onto an object just like any other texture would, and then on a per pixel basis will influence how light corresponds to hitting that specific pixel. So we can add more detail for light to interact with our objects without needing to add more geometry. It's a lot cheaper to have a RGB pixel needing to be stored in a normal map than it is to render an entirely new face for a little bit of extra detail. And that's what a normal map is. It's a color representation of the orientation that every individual pixel represents. So I'll try to show you. These pixels here are more or less untouched. They are still straight up for their normal. But then these grooves that we have here, the pixels on the edges actually point a little bit more out into that direction, right? And there's a little bit of an edge going on. So the pixel right next to it is pointing a bit in that direction, and the pixel right next to that is pointing into that direction, and so on and so forth. So you can see how we have a lot of lighting related information here packed into an image. That's what a normal map does. But we can generate our own normals for interesting, fun effects. Now that we understand that these normal colors are nothing more or less than just giving a direction through color information, we can do something like I did inside of Unity in a previous tutorial. So if we go into shading here, and I change the base color to something like green because this is grass. And if we go into shading here and we set up a point light or something like that to have a little bit of lighting going on, you can see that these faces on the back aren't being lit by the point light. But in the case of grass, it actually tends to look very bad when one side is lit very harshly and the other side is entirely in shadow. So what we can do is we can get a node called combine xyz that outputs a vector, and that vector can go straight into the normal if we want to. Now, it's set to 0, 0, 0, so it's going to pretty much not have a normal. But if we now set the normal to being z equals 1, we can see that suddenly, because all of the normals are now pointing upwards, so every single face is being told the same normal direction now. So this face over here, that's slightly bent. Actually, you are going straight up. This face over here, which is actually like facing this way, its normal is going straight up. So for lighting purposes, it's acting on the light that's coming straight down onto it, not along its orientation of its actual face. And the side effect to that is that the back sides, which were previously facing this direction, are now also facing up to the other side. And I can show you how that works, because that also works the other way around. If I set this to -1 instead, everything will be looking down for its sources of light. So the normals are all facing this direction. And I can prove that to you, because now once I move this light down, we can see the exact same look that we had before, more or less. Eevee is not a great render engine. From the light coming down up into it. Because all of its normals for every single face here are facing down. And once you understand how this works and why this works, you then can start doing some more interesting procedural stuff. But that's getting into quite a bit of vector math, which is a whole video in and of itself, which at some point I might make, but I might not, because I don't like giving myself a headache, even less giving you a headache. Hopefully this quick video has given a decent view of the basics of what a normal is and how a normal map works, because these are very fundamental things that you're going to want to understand if you want to make high quality 3D assets for any use you might want to use them for. And thanks to my patrons, you can see them on screen right now.